This is currently Apple's most powerful laptop ever, a 16-inch M1 Max MacBook Pros, 10 CPU cores, 32 GPU cores and 32 gigabytes of unified memory. But is it more powerful than an RTX 3080 laptop inside the Lenovo Legions? 7. This is one of the most powerful laptops you can get right now, and we're going to compare it with the M1 Max in everything from gaming, 3D modeling, such Blender video editing and creative workflows using Adobe apps. And we're also going to discuss some of the negatives of both platforms. Now, the Lenovo 3080 GPU has a massive 165 watt power limit, which is the highest you can possibly get in a laptop. Now, this is important because all the videos I've seen that compare the M1 Max 2 and RTX 3080 laptop are done with laptops that have around 100 watt power limits. Like the Razer Blade 15 Advanced, which actually limits the performance of the RTX 3080 by a lot. Now, the Legion 7 actually shares a lot in common with the MacBook. For example, they both have a similar form factor, being 16-inch laptops, and they're also at the top of their respective totem poles, the M1 Max being the most powerful Apple laptop and the Legion 7 being one of the most powerful Windows laptops. But the purpose of this video is not to compare the different features of Windows laptops, MacBooks. Although I have different build quality, operating systems, battery life, and all RTX laptops are massively nerfed when running on battery and not attached to a charger. But what I really want to see is differences in pure performance. How does the M1 Max chip stack up against the combined power of a Ryzen 5900HX and RTX 3080 GPU with max power limit? By the way, if you're a hardcore Apple fanboy and you just hate Windows laptops, I'll have a section at the end of the video just for you. And quick note as well, guys, I use both of these laptops on a daily basis. I've used Windows and Mac about 50-50 for the last 10 years, so I don't really have a bias towards either one. Okay, let's start with some synthetic benchmarks for the CPUs. Starting a Cinebench multi-core scores of both the M1 Max and Ryzen 100 paychecks are actually pretty comparable, with the 5900 HX only just coming out ahead, although for single-core scores, the M1 Max has the slight edge, which might show more of a difference if your workflow depends more on the speed of individual cores, for example, many Photoshop workflows. But what about creative workflows? I mean, this is why a large number of people actually buy these laptops in the first place for. Alright, let's start with After Effects, using a synthetic benchmark like Puget Bench, which tests its a whole range of After Effects workflows. The M1 Max was only just beaten by its Windows counterpart. Bear in mind that After Effects and all Adobe apps, while we're at it, is not yet optimized for Apple Silicon. That being said, if we look at a real-life project, here's a 2D animation that I used at the end of some YouTube videos. Surprisingly, the M1 Max won by about 30 seconds, and a lot of this performance difference is likely due to the M1 Max being able to access its DDR5 unified memory at a speed of 400 gigabytes per second, and After Effects is really RAM hungry. So if you can actually feed it some super fast, highly optimized RAM, it's going to really like that. Unfortunately, the Legion 7's memory isn't all that fast, actually scoring on the lower end of the DDR4 spectrum. We see the same results in Lightroom Classic and even more pronounced in Premiere Pro, which is a little bit surprising. It seems you're just more likely to see better results on Adobe apps using the M1 Max, especially if you do anything video and RAM related. Okay, let's take a look at some video editing. And for the purposes of this particular test, I'm using DaVinci Resolve Studio. It is the most up-to-date version, and it's also fully optimized and updated for Apple Silicon MacBooks. Now, this is the Studio version resolved. So, hardware acceleration is available on the Windows machine. Starting with a multicam project. Here, we have 3 streams of 4K footage playing back in 4K in real time with no issues. There is color correction applied to the clips, and we have additional layout of 4K 10-bit 422 H.264 B-roll above the multicam. Rendering out this 30-minute project in 4K and H.264, we can see an impressive result from the MacBook due to the video hardware encoders and decoders built into the M1 Max chip. Even though Resolve is a third-party app, it can still use these decoders, and in doing so actually outperforms the NVIDIA CUDA cores in the RTX 38. Now, moving on to some of the most hardcore footage you can actually shoot these days, and that is 4K 120 FPS footage from the Sony A7S Mark III, and this footage is so demanding in fact that you actually need to go out and spend a couple $100 on a specialized CF Express type of card, just to be able to shoot this footage in the first place. So importing this footage onto the timeline and scrubbing was actually smoother with less dropped frames on the M1 Max compared to the Legion. If we add stabilization to this entire 5-minute clip, the M1 Max again comes out ahead. Now, if we render out this same stabilized 5-minute clip to a 4K 120fps H.264 final file again, the M1 Max wins. But if we switch over to some 8K, red RAW footage from a red camera, this time, the results are a little bit different. Now scrubbing and real-time playback were about the same on both devices. They were a little bit choppy, but when we come to the rendering, we see a fairly big difference. So, rendering out a 2-minute 8K red RAW project in DNxHR 44410B, which is a codec more oriented to Windows workflows, we see the RTX 3080 laptop beat the M1 Max, mainly because the M1 Max couldn't take advantage of its hardware video encoders and decoders due to the incompatible red RAW footage and DNA HR codec. Okay. Now, this is the point in the video where we start to see some of the flaws. With the Apple Silicon Macs really start to become apparent, starting with Blender. I'm using the 3.1 alpha version of Blender on both devices, which introduces GPU support for cycles rendering on Apple Silicon Macs. But even then it's still kind of a disaster for the M1 Max, in every single 11 cycles render that uses the GPU. The RTX 3080 destroyed the M1 Max, because it's simply more optimized. And also uses optics, which is NVIDIA's specialized GPU accelerated artificial intelligence, that greatly reduces render times at best. The 3080 is 2 times faster than the M1 Max in scenes such as Party Tug, and at worst, it's 6 times faster in complicated scenes such as the barbershop demo. Although when restricting cycles render out to just CPU and disabling the GPU, we do see some more reasonable results, but this isn't a great real-world example, because it's almost always much quicker to render using the GPU. We also see these same performance gaps in software, such as Cinema 4D Redshift. Now again, these 3D modeling programs don't yet fully support Apple Silicon. I mean, GPU support was only just added some Blender about 3 weeks ago, with the 3.1 alpha. So we're yet to see just the true performance of Apple Silicon, but right now and in the short to medium future, you're just not going to see Apple Silicon come anywhere close to the RTX GPUs, and this wouldn't be a fair comparison if I didn't include gaming. And yes guys, I know if you want to do any kind of serious gaming, if you want to be able to play anything more than say Fortnite at low settings FPS on the Mac, you should just get a Windows gaming computer, obviously. But what if it on the hardware level? At least, the M1 Max was actually pretty good at gaming. Let's do a quick synthetic benchmark on GFX Bench. First, when the Metal API is selected for the M1 Max and DirectX 12 for the RTX laptop, the M1 Max actually beats the RTX laptop in FPS output. Although only very slightly. This just goes to show that when things are actually optimized to run on Metal, but Max is actually a pretty capable device. Unfortunately, the reality is only a very tiny percentage of games support Metal. And game developers currently have almost zero motivation to support or develop games for Apple Silicon, because Windows is still by far the most popular platform for game. So we're stuck using mainly OpenGL, which runs great on Windows, but not so great on Mac OS and Apple Silicon. As you can see here now, some OpenGL games will run on Apple Silicon, but they are running on Rosetta because they're not optimized or even natively supported on Apple Silicon Macs. So, let's look at some real-life gaming examples such as Tomb Raider, which is actually a best-case scenario because it does, in fact, have some Metal support, although, as you'll see, Matt still doesn't help much at 1080p, and with all testing done off-screen as both laptop screens have different resolutions, the RTX 3080 achieved a significantly higher FPS score, increasing the resolution to 4K. The gap between the two increased again with the RTX 3080 coming out ahead. Quick side note here guys, this is a MacBook, playing a proper AAA rated game in 4K Ultra settings and achieving a solid 30 FPS. If you obviously bump that resolution down to 1080p, you got 90 FPS, Ultra settings, which is not too bad at all. Actually, for a single-player game, that's very playable. Even if for game, you might get some drop frames, it might not be the smoothest experience, but 4K, Ultra settings, AAA-rated game being emulated on Rosetta 2 on a MacBook, that's pretty impressive. But when we take a look at some other games such as CSGO at 1080p, you might notice some weird results, and that's due to CSGO on the MacBook being artificially capped at around 100 FPS. Again, due to an being walked to around 100 FPS on a game, where traditionally you get hundreds and hundreds of frames per second. That is not great. Now, there are of course, other major differences between these two laptops like screen, refresh rate response, time etc. but for this video again we're purely looking at performance difference such as FPS, okay? So seen some of the performance differences between these two devices, but unlike the M1 Max, the performance of the RTX 3080 and Ryzen and laptops comes with a cost. Firstly, fan noise. Regardless of manufacturer, the RTX laptops sound like a plane taking off when under load. Now, these 16-inch M1 Max MacBooks fans aren't silent, but they are considerably less loud and often won't even turn on until absolutely necessary. You'll also get a lot more heat produced on the RTX laptops. Not so much from the Ryzen CPU, but the GPU really sucks up and heats up the air around it, with a lot of this transferring directly to and heating up the chassis of the laptop. And finally we come to the biggest con of the RTX laptops: they simply suck up too much electricity. To give you an example, I compare the total power draw from the wall. Both laptops used while running the Tomb Raider benchmark. The M1 Max barely sipped 90 watts of the Legion needed a monstrous 270 watts. This makes the M1 Max, purely based on wattage alone, 3 times more efficient than the RTX 3080 laptop. And if I disconnect the RTX laptop from its charger and run some of the same benchmarks on battery alone, you can see it all just falls apart. The internal battery of the RTX laptops simply cannot provide anywhere near the wattage. They need to run at 100% performance. Unlike of course the M1 Max. And why is this so important to you guys? These are laptops at the end of the day. They're designed to be used on the go. And a lot of the times that means away from electricity and a wall outlet. And for some people, even though the M1 Max still falls short in raw Blender or Cinema 4D performance, for example, the ability to get full performance out of the chip, while on battery, is still preferable to the increased performance of the RTX laptop, okay? So I think it's safe to say that the M1 Max chip is really powerful, and in some situations and workflows even more powerful than a fully spec'd out RTX 3080 laptop. Sure, the M1 Max suffers from a lack of software and optimization support in several important areas. But in those areas where it is optimized, such as video, editing, creative, workflows, or even games fully optimized for the Metal API, it matches and often exceeds the performance of the RTX 3080 laptops, while meeting 3 times less power, and being 100% portable by not needing to be attached to a charger. I think that from a purely performance perspective and ignoring all other variables like pricing, operating systems etc., the Ryzen and RTX 3080 laptops are only a better choice for 3 reasons. 1. If you need specific workflows like 3D modeling or AAA rated gaming ability, you don't mind being attached to a charger the entire time, and you need the wide compatibility that an operating system like Windows provides. But one thing's for sure, it's going to be very exciting to see how both of these platforms evolve and compete with each other over the next couple of years. Because of the last 6 months has been any indicator, it's going to be very interesting indeed. Anyway guys, hopefully you enjoyed this video. Thanks for watching, and I'll catch you in the next one.